Welcome to Spring LIB.
Hello. A ball was released with the initial velocity of 4 meters per second at an angle of 45 degrees, and we have to find the numerous parameters of the system. The geometry of the system is shown here. So V0 stands for the initial velocity, and the ball obeys the parabolic trajectory. So first, let's find the components of the velocity. The initial horizontal component of the velocity equals to the initial velocity multiplied by cosine of alpha, which is 2.83 meters per second. And the initial vertical component of the velocity equals to the initial velocity multiplied by sine of alpha, which is also 2.83 meters per second. Now, we can find the maximum height of the ball. So we need to find h max. In order to find this parameter, we have to first describe both velocities as a function of time. So the horizontal velocity doesn't change because there is no force in the horizontal in the x direction. However, in the y direction, the gravity will be initially reducing the speed of the ball. Therefore, the vertical component of the velocity equals to the initial vertical component of the velocity negative g multiplied by time. And the y coordinate is described by the following equation. So it's y0 plus the initial vertical component of the velocity multiplied by time negative gt squared over 2. So the first part equals to 0 because the ball was released from the ground. Therefore, y equals to the initial vertical component of the velocity multiplied by time, negative gt squared over 2. When the maximum height is reached, so when y equals to y maximum, the vertical velocity equals to 0. Therefore, time which is required to reach the maximum height equals to the initial vertical component of the velocity divided by g, which is 0.283 seconds. And we have to keep in mind that the total time of flight equals to the double time of reaching the maximum height. So total time of flight equals to the following. Now let's find the maximum height. So maximum height equals to initial vertical component of the velocity multiplied by the time which is required to reach the top position, which is v0y over g, negative g over 2 multiplied by squared time, or it equals to squared initial vertical component of the velocity divided by 2g, which equals to 4 meters per second multiplied by square root of 2 over 2 squared divided by 20 meters per second squared, which equals to 0.4 meters. Therefore, the maximum height is 0.4 meters. So now we need to find the time when the ball hits the ground, and apparently we've already found it. So it's total time of flight. So total time of flight equals to 2 multiplied by the initial vertical component of the velocity divided by g, which is the following. So now we have to find the distance in the horizontal direction, which will be reached when the ball meets the ground. So as we've mentioned, the horizontal component of the velocity doesn't change. That's why the horizontal distance equals to the initial horizontal component of the velocity multiplied by the time of flight, which equals to 1.6 meters. So we basically multiply this guy by this guy. So in the last part, we have to find the total speed of the ball when it meets the ground. In order to do it, we need to recall two equations. So first, the horizontal component doesn't change. But the vertical component does change. So the vertical component obeys the following equation. And when the ball hits the ground, time equals to the total time of flight. Therefore, the horizontal component doesn't change, but the vertical component equals to the initial speed sorry, some technical. Oh, now it's working. It equals to the initial speed multiplied by sine alpha negative g multiplied by the total time of flight, which equals to basically it equals to negative v0 multiplied by the sine of alpha. So basically it means that the absolute value of the final vertical component doesn't change, so just the direction is flipped. So and the total final speed equals to the square root of the sum of square of its components, which is v0 multiplied by the sine of sine square alpha plus cosine square alpha. So it numerically equals to the initial velocity. Basically its direction will be changed. So if we plot it here, the final velocity is shown here. So basically the angle will be negative 45 degree. So new alpha, so new angle between the horizontal line and the velocity equals to negative 45 degree. So now let's summarize our result. And the summary is the following. So the initial horizontal and vertical components are identical because the angle is 45 degree. Maximum height equals to 0.4 meters. Total time of flight equals to the following value. The total distance which the ball has traveled equals to 1.6 meters. And the final velocity in the absolute value equals to 4 meters per second, but the angle between the final velocity and the horizontal axis equals to -45 degree.